This tutorial demonstrates how to train a k-means clustering model using scikit-learn. The data used in this example was acquired from Kaggle. It consists of a group of 21,263 superconductors along with several properties. For each property, various other properties including the mean, the weighted mean, and the standard deviation are calculated. The dataset was originally posted to Kaggle to pose the regression problem of predicting a superconductor's critical temperature, but for our purposes, we will train a clustering model to separate the superconductors into several groups. For convenience, we have already processed this file and hosted it on our documentation page. Please find the link in the description. In order to upload training data, we first click the Dropbox button in the left sidebar. This will bring us to the Dropbox page. We can then click the Upload button. Then, when the browser's upload window appears, we navigate to where we downloaded the file in section 1 and select it for upload. If the upload was successful, the file will then be visible in the Dropbox. Next, we select the Bank Workflow button in the left sidebar, which brings us to the Bank Workflows page. We then search for the Python MLTrain clustering workflow owned by the curator's account and copy it to our account. Next, we can create a new job by selecting the Create Job button in the left sidebar. This will bring us to a new job on the Job Designer page. First, we will give the job a friendly name, such as Python ML Tutorial. Then we will click the Actions button and choose Select Workflow. This will bring up the Select Workflow dialog. We then search for Python MLTrain clustering and select it. The job designer changes now that our machine learning training workflow is selected. The Materials tab has now been replaced with a Dataset tab. Just as the Materials tab shows a preview of the materials the job will use, the Dataset tab shows a preview of the dataset once it has been selected. To select a dataset, click the Actions button and choose Select Dataset. This will bring up a Files Explorer containing all files presently on the Dropbox. Choose the training set we uploaded earlier. A preview of the data then appears on the Dataset tab, indicating the data has been successfully loaded. We have now chosen our machine learning workflow and training set. Select the Workflows tab and we can see our training workflow. We can see two sub-workflows available, Setup the Job and Machine Learning. The Setup the Job workflow contains instructions to copy in the training data. A word of caution, however, the Setup the Job workflow is automatically configured during the training process. Modifying it can disrupt creation of the predict workflow, leading to inaccurate results or a failure to generate a predict workflow. Select the Machine Learning sub-workflow by clicking on it. The following workflow units should now be visible. Setup packages and variables. This configures the job and downloads all required packages with pip. Data input. This reads the training data from disk. Train test split. This splits the data into a training set and a testing set. Data standardize. This scales the data such that it has a mean of 0 and a standard deviation of 1. Model train and predict. This handles the model's training and prediction. 2D PCA clusters plot. This draws a plot of the clusters in the training and testing set projected onto the first two principal components of the dataset. We will begin by configuring our machine learning sub-workflow. To start, select the Important Settings portion of the workflow editor. Then, set Problem Category to Clustering to state that we are solving a clustering problem. By default, the workflow will split the dataset into 4 clusters. This can be configured within the Model Train and Predict unit. We will click the Model Train and Predict unit to bring up the workflow editor. Then scroll down to line 27 and change In Clusters from 4 to 2 to split the dataset into 2 clusters. Then close the unit editor. The workflow has been configured and we are now ready to train. Click the checkmark in the upper right of the Job Designer in the header menu to save the job. We now return to the Job Explorer page with the job in a pre-submission status. We can now run the job and wait for it to complete. After a few minutes, the job will complete. We can then visit the Job's Results tab, where we will see that two properties have been calculated. The first, Machine Learning Model Train and Predict, is the predict workflow that was generated by the machine learning job. The predict workflow can be used to leverage the trained model for additional predictions on new data. In the case of clustering, this means assigning new values to the clusters identified by the model. The second result visible is Machine Learning 2D PCA Clusters Plot, which draws the clusters along their first two principal components. Each cluster represents a different group. Circles represent the training set, and squares represent the testing set. This concludes this tutorial on training a k-means clustering model with scikit-learn.